Picture this. A humble spacecraft, blasted off nearly half a century ago, is poised to achieve something mind-blowing, becoming the first human-made object to soar an entire light day from Earth. It's a testament to our relentless drive to explore the unknown. But here's where it gets controversial. As we hurl messages into the void, are we playing God by leaving our cultural footprint for potential extraterrestrial eyes? Dive in, and let's unpack this epic journey together. In just under a year from now, Voyager 1 will hit that staggering one light day mark from our planet. To grasp what a light day really means, think about it as the distance light itself, zooming at incredible 186,282 miles per second, can cover in a full 24 hours. That adds up to about 16.1 billion miles. For beginners, imagine light as the fastest messenger in the universe. In one day, it zips across roughly the equivalent of 400 trips around Earth's equator. Voyager 1, our intrepid American probe, cruising at a steady 10.6 miles per second, faces a much slower trek. According to NASA's latest projections, it'll take this clever machine over 49 years to match that light day distance. And this is the part most people miss. These vast cosmic scales make everyday measurements feel trivial, highlighting just how tiny our world is in the grand scheme. Launched on September 5, 1977, from Florida's Kennedy Space Center, atop a mighty Titan IIIe Centaur rocket, Voyager 1 has been a trailblazer. It zoomed past Jupiter in 1979 and Saturn in 1980, snapping breathtaking photos and uncovering secrets. For instance, it spotted volcanic eruptions on Jupiter's moon Io, proof that not all moons are icy balls, and even identified 3 new satellites circling Saturn. Plus, it mapped out the complex icy patterns in Saturn's rings, showing structures that look like intricate lacework. These discoveries didn't just wow astronomers, they expanded our understanding of planetary dynamics, like how gravity shapes moons and rings into mesmerizing forms. But where is Voyager 1 currently positioned? Can't visualize it? Try refreshing the page for our interactive graphics. After exiting our solar system in August 2012, it's now wandering through interstellar space, still tethered to the sun's gravitational pull. There, it's analyzing plasma waves, cosmic rays, and magnetic fields within the heliosphere, that enormous bubble of solar wind enveloping our system. While it's the most distant artifact humanity has created, it's not alone in this deep space club. Pioneers 10 and 11, sent out in 1972 and 1973 to scout Jupiter and Saturn, have long gone silent. To make sense of these immense distances, astronomers rely on light-based units. A light year, for example, is the span light travels in a year, about 5.9 trillion miles, or enough to circle Earth nearly 240,000 times. A light day, as we discussed, is a mere fraction, 16.1 billion miles. Then there's the astronomical unit, AU, a more Earth-centric measure of about 93 million miles, the average distance from our planet to the Sun. Fun fact, it takes roughly 63,241 AUs to equal 1 light-year, putting our solar system scale into perspective. For comparison, the Sun to Pluto averages around 3.7 billion miles, or about 40 AUs, still vast, but dwarfed by these light speed metrics. How much longer can Voyager 1 keep going? Engineers recently triumphed over a tricky computer hiccup that scrambled its data. Starting in November 2023, a faulty chip in the flight data subsystem stopped sending clear science and engineering info. Unable to fix the chip directly, they cleverly relocated software to another memory spot, restoring the flow. But controlling it from afar is a challenge. Signals take a full day to reach Voyager and another to get back, turning fixes into slow, deliberate processes that depend on the probe's built-in smarts and backups. Meanwhile, Voyager 1 is gradually running low on juice. Powered by 3 radioisotope thermoelectric generators, RTGs, these devices harness the heat from decaying plutonium-238 oxide to produce electricity at liftoff. They generated about 470 watts, enough to light up 4 or 5 100-watt bulbs. Now it's down to around 230 watts, like powering just 2 bulbs. To stretch its lifespan, NASA has switched off non-essential instruments on both Voyagers, aiming to keep data streaming until at least 2030. Once power fades completely, these silent sentinels will drift onward through space for eons, a quiet legacy of human ingenuity. And here's a fascinating twist. Both Voyagers carry the golden record, a 12-inch gold-plated copper disc etched with Earth's sounds and 115 images, from whale songs to mathematical diagrams, meant to showcase our world. Its protective aluminium jacket includes a needle and instructions for playback, curated by a team led by the legendary Carl Sagan. It's a bold attempt to communicate with the cosmos, but sparks debate. Is this a noble outreach or an arrogant imposition on alien civilizations? You decide. Sources: USA Today Network Reporting and Research, Reuters, NASA, Jet Propulsion Laboratory, theskylive.com. What do you think? Does sending probes like Voyager justify the risks and costs of exploration, or should we focus closer to home? Share your opinions in the comments, and let's discuss.